All right, we all know how to add. All right, you just stack the numbers, you add, and if a column is more than 10, you have to carry and all that sort of stuff, right? So the big question is, well, why do we have to carry? What's the point of that? And of course, there's a whole variety of ways to add where we don't really need to carry. But the rule that a lot of teachers give for why you have to carry when you're adding is, well, they say, well, you're only allowed to have one digit in a column, so therefore you have to carry the one. All right, so that's not a good math argument. So this video, I'm going to show you how to use a thing called number disks to make addition, make the traditional addition algorithm visual, so that you understand why we need to carry the one. So let's get started. All right, so suppose we're going to add 268 plus 147. Okay, so the first thing we're going to do is we are going to model it using a place value chart. So here is our hundreds, tens, and ones. And if I want to model what 268 looks like, it's going to look like this. There's 200. 1, 2, 3, 4, 5, 6. There's our 60. And then 1, 2, 3, 4, 5, 6, 7, 8. There is our 268. So do you see how we got that? 260 and 8. So there's our 268. Now we're going to model 147. I'm going to do that a little bit quicker. So there's 147. Now you're going to notice that I'm doing everything in 5 groups. That's because I'm honoring everything that the kindergarten teachers taught when they were teaching the kids about numbers and how they sit in the 10 frame. So that's deliberate. I'm doing that on purpose. Okay, so now what we're going to do is we're going to add, but I'm not going to really use the algorithm yet. We're going to do it over here visually first, and then once we kind of get the hang of it, as we do each step visually, I'll go over here and record it in the traditional algorithm. All right, so so the first thing we're going to do is we're going to look at all the ones. How many ones do we have? Well, we see we have 5 here and 3 here, so that's 8. And we have 5 here and 2 here, so that's 7. A quicker way of adding that would be 5 plus 5 is 10. Then we can count 11, 12, 13, 14, 15. So we have 15 ones. All right. Now the idea is we want our kiddos to understand that anytime you have 10 ones, oops, I don't want a big old fat ink. I want skinny ink. Anytime you have 10 ones, you can cash them in for 110. So those 10 ones can get grouped together and cashed in for a 10. So let's document our thinking. So what do we have in our ones now? Well, we only have these 5 ones. So we only have 5 ones. And what happened with our tens? Well, we have this extra 10 here because 8 plus 7 is 15, and we were able to cash in 10 of them for an extra 10. So our extra 10 goes right here. So you're seeing the connection between the visual representation and the algorithm. So now let's take a look at the tens. How many tens do we have? Well, we can count them real quick. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So we have enough to cash in. Here's our 10 tens. Well, what do those 10 tens equal? 100. So these 10 tens equal an extra 100, leaving just 1 10 left over. So over here in our algorithm, 1 plus 6 plus 4 is 11. We knew that over here. 1 plus 6 plus 4 is 11. And we can cash 10 of those in. And that's going to leave one extra lonely 10 right here plus we're going to have an extra 10. And that extra 10 goes right there. So you're seeing again how the visual matches with the algorithm. And now we're going to add up all the hundreds. 1, 2, 3, 4. That's pretty straightforward. We only have 4 hundreds right here. And so we're going to record that over here in our algorithm. And so the answer is 415. And sure enough, we can see that there are 4 hundreds, 1 10, and 5 ones. And that's just one quick example of how you can use number disks in a place value chart to make the traditional addition algorithm visual, and it makes it more sense as to why we need to carry. It's because 10 in one column can be cashed in to equal 1 in the next larger column. So 10 ones can be cashed in for a 10, or 10 tens can be cashed in for 100. And we can continue. 10 hundreds can be cashed in for 1,000. And this idea of this number disks in a place value chart can be used for any addition problem of whole numbers.